Okay, hello. Welcome to my Form 3 class. Okay, this is for July week 4. Okay. Um okay, just one thing. This thing is almost the same as week 3 stuff. Okay, I'm gonna repeat a little bit of it because this is one subchapter. Okay, so in week 3's video, okay, I haven't posted it. Okay, maybe I'll just post today's video because it will be almost the same. Okay, so let us begin. Okay, let us begin. Okay, today we are talking about energy. Okay, so what have we learned the previous subchapter? Let's just remind us a little bit. Okay, remind ourselves. Okay, we learned about kinetic energy, and then we learn about potential energy, which is elastic potential energy. Okay, tenaga keupayaan elastic, and we learn about gravitational potential energy. Okay, I'll just quickly write it here. Okay, why do I remind you of this? Because today we are going to use them back. Okay, we are going to use this energy back. Okay, so we learn about kinetic energy. Okay, which is tenaga kinetic, which is something moving. Okay, something moving. Okay, and then you learn about potential energy, okay, which is keupayaan. Okay, I'll do it in two languages. Okay, so of course you have elastic, okay, and of course you have gravitational. Okay, so what are the difference? Elastic elastic potential energy is when I have a rubber band. Okay, when I have a rubber band, I use that rubber band and shoot it to you. Okay, when I'm pulling the rubber band, I store energy in the rubber band. Okay, or a bowl if you like. Okay, I pull, I store energy in there. Okay, and then when I release the rubber band, when the thing hits your skin, it feels painful. Okay, because I release my energy, the energy in the rubber band onto your skin. Okay, too much of energy can be painful. That's why in a car accident you die because you receive too much energy. Okay, too much of kinetic energy. Okay, when you are in a very fast car, a lot of kinetic energy. When the thing stops, the energy is transferred to you. That's why you die. Okay, so energy can hurt you. Too much of energy can hurt you. Okay, in fact, I use a hot pan, I put it onto your face, you feel pain because that heat energy is transferred to your skin. Okay, something like that. Okay, hope you understand. Okay, and then you have gravitational energy, which is due to your height. Okay, due to your height. Okay, the position from the ground. Okay, so when you are at a higher floor, okay, imagine you have a building here. Okay, you have stairs here. Okay, you have stairs here. Climbing stairs, you need energy. In fact, climbing stairs is one of the most tiring thing to do. When you are climbing stairs, you are using energy. You are climbing with your leg muscle. Okay, so your leg muscle uses the energy to climb the stairs, and then the energy is converted into your gravitational potential energy. You store the energy in yourself. Okay, so think of it this way: you start climbing here. Okay, so as you go up, you gain GPE. Okay, which is, oh, I didn't write it in BM, elastic and gravity. Okay, so you have maximum GPE here. Okay, you have maximum GPE at the top. Okay, so max here. And then when you jump down, okay, if you decide to jump down lah, okay, somehow you're not happy, your boyfriend or girlfriend don't want you, so you're very sad, you jump down. Okay, so your GPE will be converted into KE. Okay, your potential energy will convert into kinetic energy. Okay, so more as you go down, more GPE is converting into KE. That's why you go faster. Okay, when you jump down a building, it's not like you constant speed fall down. Okay, it will be very weird. Okay, you'll be like faster and faster and faster. Okay, and then when you splat onto the ground, okay, you fell onto the ground. Most of the case you'll die. Okay, so all the kinetic energy is released. Okay, is released as what energy? Okay, if you must know, it releases as sound energy. Okay, some of it is converted to sound energy. That's why during when you jump off a building, when you hit the ground, you hear a pump sound. Okay, or during car accident, okay, when a car accident happens, KE is converted into sound energy. Kinetic is converted into sound. That's why you hear a very loud bang. Okay, so as you see here, Okay, this is what we are going to learn today. Energy is about conversion. Okay, I can convert, I can tukar. Energy, tenaga, I can convert here, convert there, convert here, convert there. But energy will never be gone. Okay, energy will not just just be gone like that. Okay, it's impossible. Physically, it's impossible. Okay, so this is what we are going to learn today. Principle of conservation of energy. Okay, prinsip keabadian tenaga. What is conservation? Okay, what is keabadian? Okay, to conserve something means, okay, English lesson, to conserve something. Okay, when you conserve your money means, okay, your money before, okay, before you go out, you have 10 ringgit. After going out, okay, you still have 10 ringgit inside your wallet. We can say that energy is conserved. Okay, saya punya wang kekal abadi, it's there. Okay, so that's the meaning of conserve. Okay, so according to this theory, conservation of energy means energy will not be lost. It will just be converted to somewhere else. Okay, I hope I hope you understand what I'm trying to say. Okay, so number one, principle of conservation of energy states that energy cannot be created or destroyed. This is the most important point. Okay, tenaga tidak boleh. Okay, I'll write the BM first. Dicipta atau, okay, sorry, atau dimusnah. Okay, energy cannot be created, cannot be destroyed. Okay, you cannot just make energy go away. Okay, let's say now your car is going very fast, you have a lot of kinetic energy. And then when you step on the brake, okay, some stupid fella in front of you, okay, something to do is something in front, you have to brake the car. When you brake, okay, this is just an example. When you brake, you are converting that kinetic energy into heat energy. Okay, how do you know heat is heat, sir? When you step on a brake, okay, the brake will press onto your wheel, okay, the wheel rotor. That's why you have heat. Okay, you have heat. Okay, if you don't believe me, next time after driving, after your daddy or mommy drives, you go down to your car, okay, and then inside your tire, you have a very shiny plate inside. That is the brake rotor. Okay, don't say I didn't warn you. You go and touch that thing, it will be sizzling hot. Okay, sizzling hot because your car was moving. Okay, just now. Now, when your daddy brakes, you convert all that KE into heat energy. Okay, you cannot just let the energy go away. Hopefully, your car will stop. Okay, energy will never just magically go away. Okay, so energy cannot be created or destroyed, but can only be converted from one form to the other. Okay, you can only convert, let's say, KE, kinetic energy, to heat, to sound, to GPE, okay, gravitational potential energy, or EPE, elastic potential energy, and so on. Okay, you can only convert energy. You cannot make them, destroy. You cannot destroy them. Okay, so this is also how it works in weight loss. Okay, let me tell you a little bit about weight loss. Okay, so okay, weight loss. Okay, let me talk a bit about weight loss. Okay, weight loss is also about energy. Okay, don't believe me? Okay, come, let's look at it. Okay, this is you. Imagine you. Okay, this is you. Okay, now, okay, food we eat has energy. Okay, food, okay, makanan has something called chemical energy. Okay, correct? You know what is chemical energy? Tenaga kimia. Okay, so something like your petrol. Petrol is a fuel, bahan api. Your food is also a fuel. You eat food to fuel your everyday. Okay, so you get your energy from chemical energy. Okay, so let's talk about weight loss. Okay, let's say let's say you are, for example, okay, for example me, I'm 66 kg. Okay, 66 kg. Okay, according to scientific report, there's a formula. Okay, you can go and search online. Okay, for me to remain my weight, okay, I need around 2,200 kilocalories. I'm sure everyone has heard of this word calorie. If you don't know, go to your kitchen, take any food out, you read the label. It will say there calories. Okay, calories means I need 2002 to run my body. My body is a machine. Okay, it's like your car. Without petrol, your car cannot run. Without food, my body cannot run. Okay, similarly. Okay, that's why when you're hungry, you feel very, very cranky. Okay, yes, real life kg. Okay, I was like 70 something. Okay, I lost some weight. Okay, so 2200 is my what we call maintenance energy. I need this energy to survive. Okay, so that my body can run. Okay, so now let's say I eat 2002. Okay, what's going to happen? My body is going to function very normally. Okay, now let's imagine I eat 2400. Okay, imagine I'm just okay. Let's not say okay. Let's imagine I eat 3000 per day. Okay, I am very happy. I eat fast food every day. I eat McD every day. Okay, I just eat 3000. I don't care. I just whack 3000 every day. I have one Big Mac every day. Okay, I'm gonna have a heart attack soon, but I don't care. Okay, so let's say I just broke up. I very sad. Every day I eat 3000. Okay, what happened? Your body will need 2002 to function. Now you have extra 800. Extra. Okay, so this extra 800 doesn't just go away. You cannot just, oh, I just breathe out the energy. No, because energy cannot be created, cannot be destroyed. If you can create energy or destroy energy, congratulations, you are better than God. Okay, which is impossible. It doesn't happen unless you're God of creation. You can create something out of thin air. Impossible. Okay, so this 800 calories will be converted, will be stored in your body as fats. Okay, fats. What is fats? You take your skin, anything they can pinch up. This is fat. Okay, this is fat. So if you can pinch a huge chunk out, you need to stop eating. Okay, you are eating too much. Okay, so this is our fats. Okay, so now let's say imagine the other way around. Now I don't eat anything. I eat 2000 every day. Just imagine I eat 2000 every day. Okay, so now you say, hey sir, I thought your body needs 2002 to function. You eat 2000, how can you survive? Okay, that's why we have fats. Okay, fats is like the power bank of your body. Okay, when you have too much, it will charge the power bank. So you store more fat lor. If you are hungry, you don't eat enough, they will take the power bank and use, you will burn away the fat. Okay, so I have negative 200. So your body will think, where can I get the extra 200? I can't create energy. So they will take it from the fat. So you take it from the fat. So eventually you will start to lose fat. Your skin will feel much looser. It's not as tight, not as big. You start to lose your fats. Okay, so losing weight is about calories in, calories out. Okay, as long you eat below of what you need. Okay, maybe okay, you might say, can I eat anything for that 2000? Yes, you can eat all McD 2000, you will still lose weight. Okay, if I eat 3000 of all healthy food like nuts, chicken breast, rice, whole wheat bread, you will still be fat because energy is energy. Okay, you cannot destroy energy, you cannot create energy. So that's the point. Okay, so remember this in your mind. Okay, don't let anyone sell you any stupid thing. Hey, come buy this pill. After eating this pill, you can eat like 5 McDonald's, you won't gain weight. That is bullshit. Okay, it doesn't happen. If that pill is so magical, this world has no more obesity. Okay, so don't believe in that. Don't let you study science, you should be smarter. Okay, don't let people sell you any stupid pill. Okay, and then after taking 5 months, then you start to think to yourself, it doesn't really work. Because it doesn't. You can't just burn energy like that. Okay, so I would say eat less, exercise more. That's the most useful way to lose weight. It's free. Okay, even eating less, you save money. You can gain some money as well. Okay, so again, let's come back to our energy thing. So as I have demonstrated just now, you cannot create energy, you cannot destroy energy. Okay, that is a fact. Okay, so that is a fact. So we can only convert energy. Okay, we can only convert energy. Okay, so today we are going to look at this oscillation system, okay, oscillating system, such as the oscillation of simple pendulum. Okay, this is what we are going to learn later. A pendulum. Okay, a pendulum is a thing lah. Okay, the swinging thing. Okay, if you have a grandfather's clock at home, you know what's a pendulum. Okay, and all a loaded spring. Okay, they are the same thing. Okay, so they use either GPE, gravitational potential energy, which is tenaga keupayaan gravity, or elastic potential energy, tenaga keupayaan elastik, or tenaga kinetic, okay, kinetic energy. Okay, so number 3, useful energy is energy in a form that can be easily converted into other forms to do work. For example, chemical energy stored in fossil fuel is useful energy because chemical energy can be easily converted to heat energy and light energy through combustion of fossil fuel. Okay, so what does it mean by useful energy? Useful energy is the energy that you can use. Okay, so let's say, for example, your car. Okay, imagine this is a car. I can draw really well. Okay, so now let's say you give it 100 joule. Okay, you can either use joule or calories. There are 2 units to calculate energy. Okay, I give it 100 joule of petrol to your car. Okay, petrol. Okay, if your car only gives you back 20 joule of kinetic energy, this is the useful energy. The other 80 heat energy, that is what we call wasted energy. Okay, this is useful energy. Okay, this is wasted energy. Okay, this is berguna. Okay, this is pembaziran. Okay, so a car is very wasting energy because 80% is converted as heat. That's why your car engine is very hot. Okay, if your car engine is 100% useful, means you touch the engine is cool. Okay, which is impossible lah. Okay, it won't happen. Okay, so anyway, so let's look at this oscillating system. Okay, let's look at this simple pendulum. Okay, what does it mean by oscillating? Okay, in BM it's called ayunan. Okay, if you have something following a pattern of coming back and go, to and fro, to and fro, to and fro, that is what we call oscillating. Okay, oscillation. Okay, so a pendulum is an oscillation because you start from here. Okay, or you start from here. Okay, the thing will just swing here and then it will come back. Swing here, it will come back. Okay, that's what we call, and it's in a fixed pattern. That's why we call it an oscillation. Okay, so what is so interesting about this pendulum? Okay, so okay, let's look at this. Okay, we look at all positions. Okay, let's start from X. Okay, let's start from X. Okay, so this is called bob here, or you want to call it ball, whatever. Okay, so this ball here, okay, is it moving here? No, at here, okay, when you swing a pendulum, at the top position, it will stop for a while. At the top position, it will stop for a while. Okay, stop for a while, stop for a while. So during X and Z, okay, the same place. Okay, X and Z is the same. So they are stopping, they are not moving, okay, for a while. So at X here, okay, at X here, GPE, gravitational potential energy, is maximum. Okay, because I'm at the highest. Okay, compared to here, okay, compared to this red line. Okay, X is the highest the bob will swing. Okay, so we can write here, okay, highest. Okay, because tertinggi, because the bob, the pendulum, is at the highest position. Okay, like I said, GPE, gravity, is depending on your height. How high are you going? Okay, if you're at Genting, your GPE is higher than you are right here. Okay, so at here, this is the highest. Okay, for KE, it is 0. Okay, 0. Why? Because not moving. Okay, at X, like I said, it will stop for a while. When you're stopping, you have 0 KE. Okay, 0. Kosong, not moving. Okay, 0 kinetic energy. When you're sitting in a car, your car is not moving, your kinetic energy is 0. Okay, kosong. Okay, so this is the simple one. Okay, now let's see what happens when I start to swing to Y. Okay, when I start to swing down. Okay, can you see when I start to swing down, I'm losing my height. Okay, when I'm losing my height, I'm losing my GPE. Okay, remember just now, GPE is height. Okay, my potential energy is my height. So as my height decrease, my GPE also decrease. Okay, my potential energy decreases. Okay, so you must say, then where does it go? Okay, it is being converted into KE. Okay, so can you see here? GPE, okay, gravitational potential energy of bob decreasing. Okay, KE of bob increasing. So from here to here, my ball starts to go faster. Okay, like that. Okay, I'm start to go faster. Okay, my height is decreasing, GPE decreasing. My speed is increasing, my KE is increasing. So can you see GPE decrease, KE increase. GPE is being slowly converted into KE. Okay, so you can put a point here, point an arrow, and then you can say convert into. Okay, ditukar kepada. Okay, it is being converted to KE. Okay, so by right at this place, okay, so let's look at position Y. Okay, let's look at position Y. Okay, at here, now my height is kosong, no more height. Okay, because this assuming this red line here is 0 height. So when my Y reaches here, the most bottom point, my GPE is 0 because height 0, GPE 0. Okay, so GPE you can say minimum, okay, or 0. And then at KE, the KE at Y, okay, because my GPE all kosong already, okay, all converted into KE. So now my KE is maximum. Okay, so can you see just now at the top here, GPE maximum, now at the bottom, KE maximum. Okay, so here, GPE maximum, and then when I swing down, GPE starts to decrease, KE starts to increase, and then reach until here, GPE 0, KE maximum. Okay, so it's like reversing. Okay, it's like reversing. Okay, very simple, huh? Okay, and then for number 2, okay, for number 2 here, motion number 2 here, it's the reverse of number 1. Okay, it's the reverse of number 1. Just now, when I come down, okay, my GPE is decreasing. Now, when I swing back up, my GPE increase back again. Okay, because my height increasing again, my height increasing again. Okay, and then for my kinetic, okay, my speed one, my speed becoming faster, my KE increase. And then as I go up, my speed decrease again. I get slower. Okay, that's why my KE will also start decreasing until I reach here. Then the exact here, at Z here, my ball is stopped for a while. So the KE is also 0, same as your X here. Okay, so let's look at number 2. Okay, from position Y to Z, GPE increasing. Okay, because my height is increasing. Okay, so you can put here. Okay, because my height increase. Okay, and then KE of bob decreasing. Okay, because my ball becomes slower. Okay, or you can say convert. Okay, or you can say the KE is converting back into GPE. Okay, so just now GPE convert to KE. Now KE convert back to GPE. Okay, I hope you're not confused. Okay, it's just the reverse. Okay, it's just the reverse. Okay, so and then at position Z, okay, this is the same as position X. Okay, so can you see GPE maximum because I'm at the highest, KE 0 because at here I'm not moving. Okay, speed 0. Okay, and then now I swing back for number 3. Okay, so this number 3 is the same as number 1. So can you see this is why we call an oscillation because the movement is repeating. Okay, to and fro, to and fro, to and fro. Okay, so for position Z to Y, okay, so it's the same as number 1. Okay, my GPE decrease, okay, because my height is decreasing. Okay, I come down, and then my KE is increasing because my ball is becoming faster again. Okay, again. So same here, because swing down, same thing. Okay, and at position Y, okay, same thing lah. Okay, and then at motion number 4, okay, as you guessed it, 4 and 2 is the same. Okay, because for Y, for 2, this is swinging up, and then for 4, also swinging up. So same motion means same energy lah. Okay, so for number 4, GPE increasing because I'm becoming higher. Okay, becoming higher. And then KE decreasing because I'm becoming slower. Okay, so I hope you can understand this diagram. Okay, yeah, I know it's very, very long-winded, like whole thing, but you know, it's a very simple concept. Okay, it's a very simple concept. Okay, so this is basically oscillation. Okay, oscillation. So I hope you can know how to um, uh, understand this part. Okay, so you might say, okay, let's say now GPE here, okay, GPE here is 100, KE is 0. Okay, And then let's say here GPE is 0, KE is 100. Okay, so can you see all GPE converted into KE? Okay, and then when I swing back up again, GPE becomes 100 again, KE becomes 0. Okay, in real life, does this happen? If it does, your pendulum will just keep swinging. Okay, means you swing your pendulum, this thing will just swing, 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 and then 5 days back, you check back, the thing's still swinging. Okay, 1 year later, you check back, still swinging. 3 years later, still swinging. Okay, and then you ask you grow up already, you have a son, you ask your son to go and check, hey, still swinging, or daddy is still swinging. And then your choo go and check, still swinging. Okay, if it happens like that, your house is haunted. Okay, it won't happen. In real life situation, it won't happen. Because in here, we are assuming 100% conversion. Okay, does it happen? No. Okay, maybe in real life, this 100 and 0, okay, but when it reaches here, the KE maybe becomes 90. Okay, then you say, hey, you start scratching your head. Sir, then where's the 10? You say energy cannot be destroyed. What? Where is the 10? The 10 got destroyed. No. Okay, the 10 is lost to the surrounding. Okay, lost to surrounding. Okay, hilang ke persekitaran. Okay, hilang ke persekitaran. Okay, so why will it lost it to surrounding? Because surrounding you have air. When ball travels through air, you have wind resistance. Okay, if you don't believe me, you go onto a motorcycle without wearing a helmet, and then you rev your motor to 100, you will feel your face super painful. Okay, don't do that, it's very dangerous. Okay, you feel super painful because of all the wind. So same thing here. When the ball and the wind brushes through, you have friction. When you have friction, you loses energy. Okay, so similarly, if you have a car, okay, if let's say this is a car, okay, so on highway, you just step onto the pedal, you step on your gas, you step it until 100 kilometers per hour. Okay, and then you let go. And then you let go. Will this thing just keep going 100? I wish. Okay, then I can just drive back to Penang without my legs touching. I can just sit there. Hey, my car will just go itself. No, it won't happen. Why? Because as you let go, car starts to slow down. Why? Because between the road and your tire, you have friction. Okay, you have friction. So you are losing this KE. Okay, because you have speed, you have KE, kinetic energy. You are losing this KE to friction. So this KE is slowly turning into heat. Harbor, tenaga harbor. That's why after driving, your tire feels hot because you have heat. Okay, you touch your tire, it feels hot. Okay, so like I said, energy cannot be created, cannot be destroyed. Okay, so same case goes to here. Okay, so can you see some energy is lost? Okay, I only get back 90 of useful energy. Remember just now? Useful energy. I only get back 90 as useful. Okay, so the other 10 lost to surrounding. Okay, and then when it comes back up, okay, this 90 maybe become 80 already. Okay, even less. Why? It's more loss to surrounding. Okay, that's why, okay, they actually did this experiment on YouTube. You can go and try. You can go and search, okay, the pendulum experiment. Okay, the guy stands here, okay, and then he uses a very big pendulum. Okay, the pendulum he used a bowling ball. Okay, how heavy is a bowling ball? It's like what, 10 kg. Okay, he uses a bowling ball. Okay, and then he released this bowling ball. So this bowling ball swings here. Okay, and then when it swings back, does it hit his face? No. Okay, because when I swing here and swing back, I lost some energy. I cannot go back to the height. Okay, let's say I release from my nose. I release, so it will go there, and then it will come back. So will it touch my nose again? No, because like I said, you lost energy in the process. Okay, so when you release here, when the pendulum comes swimming back, maybe it will reach here. Okay, you will see like 2-3 cm already because some energy is lost. Okay, so what is that a black thing? Is it a black box? Okay, I don't know. Sometimes my halfway they will have some. Oh, just now, no more already. Okay, so wait, let me check again. Okay, oh, no more. Okay, so let's come back to this. Okay, so like I said, energy will always be lost to surrounding. Okay, you can't have 100% perfect system. Impossible. Okay, so like here you see 90 is good enough. Okay, like for our car, you are only using 20% of energy to move. The other 80 you are wasting it as heat. Okay, so you must say, sir, then that's a very stupid design, isn't it? Yes, it is. Our combustion engine is a very stupid design, but we are still using it because that's the best thing we have. Okay, that's why now we are slowly moving into electric energy. Electric car, you know Tesla? Okay, you know Tesla? Okay, electric car is 80% useful. Okay, I'm wasting only 20. Compared to this, we are wasting 80. Okay, all that energy is wasted as heat and sound. That's why your engine is very noisy. You have the sound. Okay, when a car is started, you know, because you have sound energy. Okay, some of that petrol is converted into sound and heat. Okay, you are only using 20 to move. Okay, that's a very stupid if you ask me. If you use $100 to get back something 20 bucks, that's a shitty deal if you ask me. Okay, let's say you bought something. Let's say you bought a mouse. Okay, a computer mouse. This mouse is worth 20 ringgit. You use 100 ringgit and buy. Okay, that's the worst deal in my life. Okay, but it happens in our car. It happens. Okay, that's why all this heat. Okay, extra info for you. All this heat, where does it go? It goes to the atmosphere. Okay, so one car gives 80. So we have millions and billions of cars. That's why the atmosphere is getting hotter and hotter and hotter and hotter. That's why we have global warming. Okay, that's why if you switch to electric car, you solve 60% of the problem. Okay, but then again, that is wishful thinking lah. Okay, so Tesla is the future, but for now, it's very expensive. Okay, so a Tesla can buy like what 20, 30 Myvis. Okay, stupid expensive. Okay, unless you're so super rich, they say you are like millionaire, billionaire, and then you say, oh, I care about the environment, I only buy Tesla. Then you know what? That's good for you. Okay, but impossible for us. Okay, Malaysians, we are too poor. Okay, sucks to say that. Okay, anyway, so if you look at this spring, it's the same thing. Okay, it's just that just now we use GPE. Now we use EPE. Okay, elastic potential energy. Instead of using string, okay, instead of height, now we use spring. Okay, we use spring. So that's the difference. Okay, the explanation is the same. So at position X, okay, which is at the most bottom here, okay, so the EPE is maximum because I'm stretching the spring. Okay, I stretch the spring down, so my maximum energy stored in the spring, and then KE is 0 because the block is not moving. Okay, and then when I release the block will come swinging like that, Okay, so from position X to Y, okay, from X to Y here, okay, as the block moves up, okay, the EPE is decreasing, okay, because my springs shortens, okay, and then my block moves faster. Okay, so again, same explanation. My block moves faster. Okay, so this one spring becomes shorter. Okay, spring shorter. And then at position Y, okay, at position Y here, okay, the KE is maximum. At here, the speed is the fastest. Okay, so this is what we call equilibrium position, same as here. Okay, and then as it moves up, reverse again. My EPE is increasing, my KE, my kinetic is decreasing. So it's like a up and down, up and down. Okay, same thing as the pendulum. Okay, so you might say, sir, I don't want to study this, can? Can. Okay, mostly they will ask about pendulum. Okay, this is more common. Okay, in fact, if you go to Form 4, next time if you study physics, okay, you will see this all the time. Okay, this is why a lot of my students they hate physics to the guts because you need to calculate everything here. Okay, there's so many formulas to just a stupid simple pendulum. So many formulas, one answer. Yes. Okay, it's very simple yet very complicated. Okay, I don't know. I hope you understand what I'm trying to say. Okay, so anyway, so transformation of kinetic energy and potential energy in a closed system. Okay, what does it mean by a closed system? Okay, closed system means the energy is contained in the system. Okay, it means if there's no energy loss. Okay, assuming perfect world, no energy loss. You throw the bowling ball. from your nose, it will swing back and touch your nose. No energy loss. Okay, perfect scenario. Okay, so in a closed system, the transformation of energy between PE, potential energy, and kinetic energy obeys the principle of conservation of energy. Okay, our prinsip keabadian tenaga. Okay, everything will follow. Okay, this is system tertutup. Okay, and then number 2, therefore the total PE and KE in a closed system is constant. Okay, assuming GPE 100, KE 0 will convert into KE, sorry, I reversed that thing. Okay, will convert into GPE 0, KE 100. Okay, this is perfect world. Okay, of course, it doesn't happen like this. Okay, so based on the principle of conservation of energy, energy can transform, okay, or convert lah. Yeah, I don't like to use transform, I like to use convert. Okay, convert, okay, from one form to another. When energy converts, or transform, small portion of energy is converted into useful energy. A large portion is converted into wasted energy. Okay, so this is where it's not perfect world. Okay, a lot of energy is wasted. Like our car, like I said, 80% is wasted as heat, as not useful energy. Okay, as wasted energy. Okay, so a closed system in a system which there is no external force such as friction. Okay, can you imagine a world without friction? Oh, my car will just glide all the way to Penang. I just need to step my gas to 100, then the car will glide itself. Okay, no, it doesn't happen. Okay, there is no such thing as zero friction. Okay, it doesn't happen. Okay, so hence heat energy is not produced in a closed system. Okay, there's no heat. Can you imagine a machine without heat? 100% efficiency. Imagine a light with zero heat. Okay, so just by comparison, last time our filament lamp, okay, our atuk nenek guna punya, the yellow color one, okay, that thing is 8% efficiency. What does it mean? Means 92% is wasted. Okay, that's why our nenek punya masa, okay, the bulb is so dim. Okay, it's not bright at all. Okay, and then during our mommy daddy's time, we have fluorescent lamp. Okay, fluorescent lamp. Okay, some of you might still be using this at home. Okay, fluorescent lamp. Okay, this is slightly better. This is around 20% to 30% efficiency. Okay, so when you touch this bulb, it's so damn hot. Okay, it's like your water heater. Okay, this thing can be a water heater more than a light bulb because it doesn't do such a good job in providing light, but it does a super awesome job in providing heat. Okay, so for our fluorescent, okay, this is still around 70, okay, 80 to 70, 70 to 80% wasted. That's why when you touch fluorescent lamp, it's still a bit hot. Okay, and then for our time, very awesome, we have something called LED. Okay, this is awesome technology because LED efficiency is around 90%. Okay, only 10% wasted. That's why when you touch LED, you don't feel hot. It's like, maybe it's warm a little bit, okay, but it's not hot at all. And it's super bright. Okay, that's why if you change all your lights at your home to LED, you save a lot of electricity. Okay, because of the efficiency. Can you see? From 30 to 90, that's a big jump. Okay, if you score 30 in an exam, you'll be spanked to high heaven. But if you score 90 in an exam, congratulations, you're so awesome. Okay, so that's how big the difference is. Okay, so it's about the conversion of energy. So this is basically the summary of the chart lah. Wow, sir, you explained to so long. Yes, this is the summary. Okay, long story short. So at the top position, PE maximum, okay, or GPE lah. Okay, GPE maximum. Okay, because I'm at the highest. KE 0 because I'm not moving. Okay, when I come down, okay, PE here minimum because my height is 0, and then my KE maximum because here is the fastest. Okay, so imagine if you stand here, the pendulum will whack your face at maximum force. Okay, compared to here, if you stand here. Okay, and then come back to here, same thing as here again. You have PE, GPE maximum, and then you have KE 0. So this thing will keep going on until all energy is lost. Maybe it will take like what, 5 minutes, and then this thing will be stopped again. Okay, so okay, what the hell is this, sir? Okay, you can don't care. Okay, doesn't matter. Basically, this is the graph of KE and GPE. So can you see? this dotted line is KE. So my KE starts from 0, okay, 0. I go to maximum, okay, and then I go back to 0 again. Okay, and then for GPE is the reverse. I start from maximum, okay, maximum, and then I go to 0, I go to maximum. I go to 0, I go to maximum. Basically, this is it. Okay, so if they ask you this exam, maybe they will ask you to label which is GPE, which is KE. Okay, common sense lah, if you ask me. It is more of a common sense stuff. Okay, so let's try out some examples, okay, calculations. Okay, so let's look at question A. Okay, imagine this is a BB gun. Okay, so the length of the spring, okay, you know, when you see spring, immediately you write EPE here. Okay, this is EPE. When you see spring, is EPE. When you see height, is GPE. Okay, so EPE, okay, of this toy pistol is 300 mm. Okay, so 300. Oh, okay. So that's the full length is like this. Okay, the spring is like this. Okay, and then if a force of 5 Newton is used to compress the spring until the length becomes 50, okay, calculate the maximum speed of the plastic ball of mass 50 when it is fired. Okay, so now what energy is being converted? When I store my ball like this, I have EPE. When I press the trigger, okay, this EPE will be converted into KE. Okay, my spring will bounce the ball. So EPE will be converted into KE. Okay, so state an assumption that is made solving this problem. Okay, so imagine, okay, let's assume 100% conversion, no energy loss, you cannot calculate energy loss. Impossible to calculate energy loss because energy loss depends on a lot of factors. Okay, maybe this surface is smooth, this surface is rough, then different. Okay, let's just imagine all EPE is converted into KE. So you can just write this formula, EPE equals to KE. Okay, elastic sama dengan kinetic. Because if let's say my EPE is 100, everything will be converted to 100 of KE. Okay, so you write this formula first. Okay, because this formula shows the teacher that you know what energy is being converted. Okay, so now what do you do next? Okay, you use formula. Okay, what's the formula again? Oh shit, you've forgotten. Never mind. Okay, for EPE, we use half Fx. Okay, F is the force, X is the extension. How long are you pressing the spring? Okay, and then for GPE, the formula is mgh. Okay, m is the mass, g is 10. It's always 10 unless you go to Mars. Okay, Earth is always 10 g. Okay, the gravitational acceleration, and then h is my height. Okay, because GPE is related to height. Of course, you have a height there. Okay, and then for KE, the formula is half mv squared. Okay, half mv squared. So these you need to memorize, you need to know. Okay, I'm not sure whether they will give this in exam. Okay, if your teacher is the kind-hearted one, maybe she will put down at the question there, tips. KE formula is half mv squared. If your teacher is a crazy gila one, okay, she will torture you to death. She won't give you any. Okay, then you just sit there and look at your formula. Oh, you die, I've forgotten how. Wrong case lah. Okay, so our formula for EPE is half Fx. Okay, KE is half mv squared. Okay, so let's make our problem simple. This half we can cut away. Okay, because this is your linear equation. You move there, move here, you become no more lah. Okay, so what's my F? Okay, my F is 5. Okay, I use 5 Newton, so 5. Okay, what's my X? X is my extension. How long I press my spring. Okay, my spring was 300. Okay, and then I press it to 50. So my extension is 250. I press the spring for 250. Remember, X is how much you press or pull the spring. Okay, it doesn't matter pull or push, same thing. You are still storing energy. Okay, so that is how much you move the spring. Okay, so 250 mm, can you just straight away sub in? No, you have to convert this to SI unit. Okay, so mm to convert to meter. Okay, if you cannot do it quickly, okay, 250 mm is 25 cm. Okay, 25 cm is 0.25 mm. Sorry, not mm, m. Okay, or you can just really divide by 1000, you still get 0.25. Okay, so just take your own way, use your own comfortable way. Okay, so now I know that my x is 0.25. Okay, 0.25. Next, what's my m? What's the mass of the ball? Okay, the mass of the ball is 50 gram. Can you use 50? No, because I need my SI unit. Okay, can you see? That's why we need to fix everything to SI unit. Okay, that's why a lot of students will be caught here. Okay, so please use your SI unit. So 50 gram divided by 1000. Okay, 1, 2, 3, you get 0.05 kg. Okay, don't ask me how to convert. You need to go back to primary school. Okay, so 0.05. Okay, and then calculate the maximum speed of the ball. So V is the velocity or the speed. Kelajuan. We don't know. Okay, so we just leave it there. Okay, so V equals to 5 times 0.25 divide by 0.05. Okay, you move this down. Okay, and then this 2, you move here, it becomes square root. Okay, so let me get my calculator. Okay, so 5 times 0.25 divided by 0.05. Okay, I get 25. So square root of 25, you should get 5. Okay, I use a calculator lah. Okay, 5. What's the unit? Okay, speed is ms minus 1. Yeah, this one you have to know. Okay, if your unit is wrong, it'll be wrong. So you have to know. Okay, so okay, you might say, sir, if I've forgotten how, okay, think of it this way. The speed we know usually is km per second, per hour. Then you look at your daddy's car, okay, you look at your car, you have the meter, isn't it? Okay, and down there it says kilometer per hour. Okay, so at highway we speed at 110. Okay, so instead of using km, because km is not SI unit, we use meter. Okay, and then for hour, we don't use hour for SI unit, we use second. So per second, so meter per second. Okay, so remember this thing. Okay, whenever you forget, remember the speed trap sign. Okay, 110 kilometer per hour. Okay, so that is the maximum speed my ball will go. Okay, my maximum speed my ball will go. Okay, so in real life, can you reach this speed? No. Why? Because you have some energy loss. Okay, the ball, okay, maybe the gun here is rough, you have friction. Okay, maybe you use a speed camera, this ball is like 4.5 meter per second. If you ask me, that's good enough lah. Okay, you only lose at 0.5. Okay, what if you put a speed camera, the ball is 5.9? That means your calculation is wrong. Okay, or you use the wrong spring. Okay, you just assume something wrong. Okay, because you can't gain energy. This is gaining energy. Okay, it's like saying, oh, the bullet move faster than what it says. It won't happen. Okay, unless you have the hand of God. When you press the trigger, you can channel energy to the gun, and then the gun somehow will fire faster. Impossible. Okay, no such thing. Okay, so from this calculation, we can know the ball will fly at 5. Okay, rather slow lah. Okay, 5 is a very slow speed. Okay, so state an assumption. Okay, what did you do during this assumption? Okay, if they ask about assumption, you always write this. Okay, this is in a closed system. Okay, system tertutup, or you can say no friction. Okay, but when you say closed system, it is automatically understood that it has no friction. Okay, assuming this is in a closed system. Okay, because if it is not 100% conversion, okay, if it is not 100% to EB to KE, we cannot calculate. Okay, because in real life, we don't know the friction. Okay, friction changes everywhere. Okay, what if you have air resistance some more? We cannot estimate. Okay, that's why firing a sniper is very hard. Okay, you have to accommodate. Okay, if you have played any sniper game, or if you have watched any sniper movies, you know, you use your sniper. Okay, a sniper has a crosshair. Okay, a crosshair. Okay, if you aim someone's head here, okay, if the guy is like 1 kilometer away, hey, why is the bullet flying somewhere else? Why is the bullet hitting here? Okay, because you need to account for wind. Okay, you need to account for the weight of the bullet. Okay, a bullet has weight. That's why you have gravity. A bullet will travel down. That's why when you fire an arrow will not go straight. An arrow will go down. Okay, so this is why being a sniper, you need to accommodate for wind. Okay, that's why being a shooter is not easy. You need to accommodate for all this. Okay, and then different wind, different accommodation. Okay, yes, windage adjustment, yes, good. Okay, so that's why when you see sniper, usually a sniper beside there's a guy that tells him what is the wind speed now, where is it blowing. Okay, you cannot you have to adjust the thing, and then how far is the target. Okay, if you were to assassinate, let's say Donald Trump, okay, for example, okay, you think he's a very stupid guy, you want to murder him. Okay, so yes, you have a spotter there. Okay, Takan, you say, Mr. President, can you wait? Then you pull out your measuring tape. Oh, this is 300 meter. Okay, you have to agar it yourself. Okay, so that's why being a sniper takes a lot of skills. Okay, that's why they have marksmanship training and everything. Okay, and then when you shoot a sniper, of course you have to hold your breath, because when you are breathing, you're moving your crosshair, you're moving your rifle, then you will lose your accuracy. Okay, it's not easy. Okay, you watch any sniper movie or you play any game, then you will know. Okay, so very interesting stuff. This is very interesting physics. Okay, anyway, so let's look at question B. Okay, so a durian is dropped from a height of 5 meters. When you see height, you know this is GPE. Okay, for me, I like to write out stuff lah. Okay, so that I know what's happening. Okay, so what is the speed of the durian just before it reaches the floor? Okay, so now what energy is being converted to what energy? You have GPE being converted into KE. Okay, GPE converted to KE. So again, I assume this is closed system. There is no energy loss here and there. Okay, so okay, oh sorry, okay, so GPE formula, that is your mgh. Okay, KE is half mv squared. Okay, this is 90%. You will do this. Okay, GPE to KE. Okay, very simple now. You just cut away your m. Both sides got m. Okay, that's why you see they didn't give you the mass of the durian, did they? No. Then you start panicking. Shit, no mass. How to calculate? Okay, you don't need the mass. You can just cut away. Okay, and then what is the G? Okay, let's sub in our value. G is always 10. Always. Unless you're in mass, then different story. Okay, H. What is the height? Height is 5 meter. Now they give you meters, senang for you lah. Okay, and then 1/2. And then what is the speed when it reaches the floor? So V squared. Okay, we don't know the speed. So move everything out. Okay, 10 times 5 is 50. 50 times 2 is 100. 100 square root. Right. You know, for me, sometimes your teacher very, you know, they need the working and all. Okay, just write for them lah. Okay, this is square root of 10. 100 is 10. Okay, meter per second. Okay, 100 meter per second. So this is the speed the durian will hit the floor. Okay, so it is quite fast. Okay, so 10 meter per second is around 0.01 divided by times 3,600. Okay, oh, this is pretty damn fast. Okay, if this thing hits your head, it's gonna hurt. Okay, or you will die. Okay, so anyway, next let's look at C. Okay, let's look at the last question. Okay, so C, the figure shows a stone weighs 20 gram. Okay, now they give you the weight placed on a stretched band of catapult. Okay, what is a catapult? Okay, catapult is this thing lah. Okay, you have something like a spoon here. Okay, you put this thing, and then there's a string here. Okay, when you release, the thing will just swing out. Okay, so catapult. Okay, or small string catapult lah. Okay, so you see string elastic. Okay, you see elastic. So you know this is EPE. Okay, so the EPE on the rubber band is 0.5. You see now they cut the thing simple and they just give you the EPE is 0.5. Okay, calculate the height of the stone if the catapult it releases 90 degree upwards. Okay, you say, hey, sir, why is it 90? Very simple, just assuming it shoots straight upward lah. Okay, so what energy is being converted now? This is from EPE to GPE. Okay, because I have height. Okay, because of height, I'm shooting this up. Okay, see how high it can go. Okay, so EPE equals to GPE. So EPE, you don't need to put formula here because they straight away give you 0.5. You just put 0.5 inside. Okay, so 0.5. So my GPE is mgh. Okay, so m is 20. Is it 20? Please convert to SI unit first, which is 0.02. Okay, and then G is 10 always. Okay, so height we don't know. Height is what we want to find. Okay, so height equals to 0.5 divided by 0.02 times 10 is 0.2. So 0.5 divided by 0.2. Okay, so what do you get here? You should get 2.5 meter. Okay, just doing it quick lah. Okay, so in real life, can you reach 2.5? No, because as you go up, you have air resistance. Okay, you have wind friction and whatnot. Okay, and how do you know you're shooting 90%, 90 degrees straight? Okay, there will be some error. Okay, so this is how you calculate. Okay, you can even calculate if now, okay, if let's say now you were to jump from 30th floor, what's the speed when you hit the ground? Okay, very easy. Okay, come on, teach you how to calculate. Okay, so if you were to jump down, okay, let's kill ourselves with physics. Okay, so GPE equals to KE. Okay, because you're climbing up, okay, GPE Okay, and then you jump down, that's your KE. Okay, so mgh equals to half mv squared. Okay, so you don't need to know your mass. Okay, mass is not important. No matter you're 70 kg or 30 kg, you jump down from the same floor, you hit the floor at the same speed. Okay, so G is 10. So height, how tall is 30 floor? Assuming one floor is 3 meter. Okay, you can take your tape and measure. Usually one floor is 3 meter. So 3 meter times 30, that is 90 meter lah. Okay, so 1/2 v squared. Okay, so use your calculator. 10 times 90 is 900. 900 times 2 is 1008. Okay, v equals to square root of 1008. Okay, so let me get my calculator. Oh, my calculator doesn't have a square root here. Okay, so square root of 1008 should be around 40 something. Okay, 40 something, 40 plus meter per second. You will for sure die. Okay, for sure. Okay, because that is such a stupid speed. Okay, I think it's around few hundred kilometer per hour. You'll create a loud bang. Okay, a loud bang, and then you'll be mess everywhere. Okay, depends on how you land. If you land head first, of course your head is gonna be like a watermelon and splash everywhere. Okay, so who say physics is not fun? Okay, so this is how you calculate something. For me, I think this is pretty damn interesting. Okay, this is how they used to create, like gun. Okay, of course a real gun doesn't use spring lah. Okay, so a gun doesn't use spring. A gun uses gunpowder. It uses explosion and then it will propel the bullet forward. Okay, that is military engineering. Okay, so if you're interested, you can go and study gun. Okay, primer. Okay, some of you know. Okay, so and then that's why bullets they have few sizes and what. Okay, and then the gun barrel. Okay, to prevent. Usually, when you shoot a bullet doesn't just travel straight; it will spin. Okay, because the gun barrel inside has a. Okay, it will make the bullet spin. Because if your bullet is spinning, it is less likely to be affected by gravity. Okay, everything is physics. Okay, it's all physics. Okay, so I think that's it for today. Okay, I hope you learned something new. Okay, and for the exercise, okay, for this part, okay, I will be releasing an exercise video. Okay, so this thing I'll put in GC, and then of course the exercise video I'll upload it differently. Okay, so in the end you get 1.5. You still get 1.5 hour of lesson. Okay, so that's it for today. I hope you learned something new. Okay, very interesting lesson if you ask me. I hope I didn't bore you to death. Okay, you not only learn about guns, you learn how to lose weight. Okay, yay! Okay, win! You learn 2 things today. Okay, so thank you for listening. I will see you again next week. Bye bye. Oh, there's a question here. May I know what subject do you teach? I just teach science and bio. Science and bio. I didn't teach physics. Okay, so okay, bye bye. See you next week.